Hello, my dear students. Once again, I welcome you all to KLS Gokte PU College of Commerce and Science, Belgavi. This is our second lecture on the topic haloalkane and haloarine. This is Mr. Akash Vasan Nesarkar, lecturer, Department of Chemistry. So, in the last class, we studied about the haloalkane and the types of haloalkane based on the number of halogen and based on the hybridization of carbon to which halogen atom is attached. And in today's class, we will see the nomenclature and the preparation and also the properties of haloalkane and haloarine. So the nomenclature in organic chemistry is very important. So every molecule has a common name as well as a IUPAC name. The common name of haloalkane is also important as well as the IUPAC nomenclature. So let us start to study the nomenclature of haloalkane. So first we'll study the common, or it is also called as a trivial system. The common names of alkyl halides are derived by naming the alkyl group followed by the halide. So common name can be named as alkyl group followed by halogen. So means first we have to name the alkyl group of a molecule, then the halogen which is present in that molecule. In dihalogen compounds, gem dihalides are named as alkylidine halides. So if dihalogen compound is present, then in that you have to name as a alkylidine halides. And vicinal halides are named as alkyline dihalides. If haloarenes are named as halogen derivatives of benzene. If haloarene is present, then you have to name as a halogen derivatives of benzene. For example, we'll study here. Suppose if the molecule is CH3Cl, the molecule is CH3Cl, then the common name of this molecule, how we are going to write? First you have to name the alkyl group present in this molecule followed by the halogen group present in this molecule. So which is the alkyl group? Alkyl group means hydrocarbon, that is this is your alkyl group. So what is this? This is methyl. This is methyl followed by the name of halogen. Which halogen it is? Chloride or chlorine. So in common name you can say it is chloride. So methyl chloride. Don't write as a chlorine. Methyl chlorine is wrong. You should write methyl chloride. So this is the common name of CH3Cl, that is methyl chloride is the common name of this molecule. Are you getting? First you have to name the alkyl group, then followed by the name of halogen, so it is methyl chloride. Let us take another example. If I write CH3 CH2 Br, okay, so in this molecule alkyl group is also present and hydrogen group is also present. So common name of this molecule, first we have to name the alkyl group. So two carbon atoms are there, so it is ethyl followed by the halogen bromide. So name of this molecule is ethyl bromides. So this is the common name of CH3CH2Br. So I hope you are understanding, right? Next, let us try the another example. CH3 CH CH2 Cl CH3. Now here methyl branching is present, okay, and you know that if one branching is present, this type of branching, then it is called as a iso, right? So how many carbon atoms are present? Totally 1 2 3 4. So if 4 carbon atoms are present, then it is butyl. 4 carbon atoms are present, then it is butyl. Which butyl? Isobutyl. Which halogen is present? again chlorine. So your name should be isobutyl chloride. So this is a common name of this molecule. Yes. Okay, now let us move further towards the IUPAC nomenclature. So in examination the IUPAC nomenclature can be asked, and this is very important. So in IUPAC system, halogen derivatives of hydrocarbon are named as halohydrocarbon. So in IUPAC nomenclature you have to name the molecule like halohydrocarbon. Halohydrocarbon, it means first you have to name the halogen present in the molecule followed by the name of hydrocarbon. So in this exactly reverse manner as we seen in a common name. In common name we first name the hydrocarbon then followed by the name of halogen, but in case of IUPAC nomenclature first you have to name the halo means you have to write chloro, bromo, iodo, don't write chloride and all those things. Okay, so it is clearly mentioned you have to name first halo followed by the name of hydrocarbon. Okay, for example, if it is alkyl halide, then how we are going to write this name in a IUPAC nomenclature? First you have to name the halide group like halo. Next followed by alkyl means it is alkane, so halo alkane you have to name. So haloalkane is the IUPAC nomenclature of alkyl halide. Okay, simple, it is hydrocarbon and the halo group you have to name. Fine. So this is very important. Remember in IUPAC nomenclature you have to name like halohydrocarbon. Suppose if it is aryl halides, aryl means aromatic halogen group. Okay, then you have to name as halobenzene. So this is your aromatic nomenclature. Halobenzene you have to write if benzene ring is present or aromatic group. Now let us try some examples. Okay, so on the screen some examples are present here. Also we see this common name as well as IUPAC name. So first of all CH3CH2, the first example CH3CH2CHCl CH3. Okay, so the chlorine group is attached to secondary carbon and 4 carbon atoms are present. See here CH3 CH2 CH Cl CH3. Okay, so this carbon is secondary carbon and 4 carbon atoms are present. So how to name common name? First alkyl group. So which is the first alkyl group? Carbon group. Okay, 1 2 3 4. So secondary butyl, which halogen is present? Chloride. So this is the common name of this molecule, secondary butyl chloride. Next, its IUPAC nomenclature. Its IUPAC nomenclature is very easy. Okay, CH3 CH Cl CH3 CH2. Okay, so in IUPAC nomenclature numberings are important. So start to numbering to that side where the functional group is present. So this side the functional group is present 1 2 3 4, because this carbon atom will get list number, and that is according to the IUPAC nomenclature or IUPAC rules. Fine. So 2 chloro, because you have to first name halo group, so it is 2 chloro 1 2 3 4. So 4 carbon atom means butane, 2 chloro butane. Are you getting? 2 chloro butane. So this is the IUPAC nomenclature of that molecule. Next one, CH3 thrice CCH2Br. So this is very important. CH3 thrice CCH2Br. So here the branchings are present and it is neopentyl bromide. So 5 carbon atoms are present, so it is pentyl. So neopentyl bromide. Whereas the IUPAC name is 1 bromo 2,2-dimethyl propane. 1 bromo 2,2-dimethyl propane. Next one is CH3 C C CH3 CH3 Br. Now what is the common name? The common name is very easy. This is a tertiary carbon, So tertiary carbon, how many carbon atoms are present? 1 2 3 4. Tertiary butyl bromide. So this is a common name of this, tertiary butyl bromide. What is the IUPAC nomenclature? First start the numbering from that where the carbon atom has a functional group. So if I am numbering from this or this, it is same. So numbering 1 2 3. Okay, 2 bromo. Okay, 2 2 di 2 bromo, 2 methyl propane. 2 bromo 2 methyl propane is the IUPAC nomenclature, IUPAC name of tertiary butyl bromide. Now next one is here, CH2CHCl. So CH2 double bond CH is the vinyl carbon, so vinyl chloride, whereas IUPAC name is chloroethene. Chloroethene is the IUPAC nomenclature. Next, allyl bromide. So IUPAC nomenclature is 3-bromopropane. Suppose if benzene ring is present, then how to name the common name as well as the IUPAC name? So in common name we have to use the ortho, para, meta. These are the prefix, right? Now, so this molecule, let us take. So at ortho position, chlorine is present because methyl group get first priority. So ortho chloro, this entire group is what? Toluene. If benzene ring having methyl group, then it is called as a toluene. So this is a Cl. So ortho chloro, this one is what? Chlorine. So that is a common name, whereas IUPAC nomenclature is different one now. So IUPAC nomenclature, how you are going to write? So numbering start from the functional group 1 2 3 4 5 6. So 1 chloro 2 methyl benzene, 1 chloro 2 methyl benzene, or you can also write down 2 chlorotoluene if you give the priority to methyl group. So 1 chloro 2 methyl benzene is also right, or 1 methyl 2 2 chloro toluene is also right. 2 chloro toluene is also right. So these are the common IUPAC nomenclature. Now next example was benzene ring CH2Cl. So here the name, common name is what? Benzyl chloride. So benzene attached to CH2, benzene attached to CH2, it is known as a benzyl. So it is contains one chlorine group, so it is benzyl chloride. Benzyl chloride. Now IUPAC nomenclature is what? Chloro, first haloname, then phenyl, this one is what? Methane. Chlorophenyl methane. The IUPAC nomenclature is what? Chlorophenyl methane. Now these are the simple ones. CH2Cl means what? Methylene chloride, or dichloro, IUPAC name is dichloromethane. CHCl3, just we have discussed this, chloroform or trichloromethane. Tribromomethane, that is bromoform. Tetrachloromethane, that is the IUPAC name of CCl4 or carbon tetrachloride. And this one is what? N-propyl fluoride or 1-fluoropropane. So these are the common name and the IUPAC names of some open chain compound as well as aromatic compound. Now these are the some important compounds and their names. The first one is what? Benzene ring. Chlorine attached to the benzene ring, so it is called as a chlorobenzene. Bromine attached to the benzene ring, bromobenzene. Iodine attached to the benzene ring, iodobenzene. Now 2 bromo, 2 halo groups attached to the benzene ring. Then how to name? First start to number 1 2 3 4 5 6. Okay, so 1 2 dibromo, you have to use the prefix di because 2 bromines are present. 1 2 dibromobenzene. Now 1 2 3, at 1 and 3rd position chlorine are present, right? So 1 3 dichlorobenzene. Okay, 1 3 dichlorobenzene. IUPAC name if you want, then it is ortho dibromobenzene, meta dichlorobenzene. Now 1 and 4th position 1 4 dichlorobenzene, or para, to para position 2 chlorine atoms are present, so para dichlorobenzene. Next one, it is 1 2 3 3 chlorotoluene or metachlorotoluene, you can also name. Next one, phenyl bromoethene, phenyl bromoethane, or benzyl bromide, or benzyl bromide. So this is about the nomenclature of haloalkanes as well as haloals. So haloalkanes, their common name, and haloarenes also their common name we have studied. Also we studied the IUPAC name. Now the next one is preparation of haloalkanes. So we can prepare the haloalkanes from various functional groups. Okay, so there are number of method of preparation of haloalkanes. So the first one is from alcohol. We know that alcohol means ROH, right? This is a functional group of alcohol. Yes, do you remember, right? Alcohol. So by using various different reagent, we can prepare the haloalkane from alcohol. Okay, by using various reagent. So let us learn one by one. So the first one is reaction of halogen acid. Reaction of halogen acid. So alcohols can be converted into haloalkane by the action of halogen acid, like dry HCl, okay, di HBr or HI. These are the halogen acids in the presence of unhydrous zinc chloride. In the presence of unhydrous zinc chloride, that is a dehydrating agent which removes the water molecule. The reaction can be represented as, now this reaction we can represent as, see here, this is our alcohol, this is a halogen acid in the presence of unhydrous zinc chloride which is a dehydrating agent, and mixture of HCl and unhydrous zinc chloride is known as Lucas reagent. The mixture of HCl and unhydrous zinc chloride is known as Lucas reagent. Lucas reagent. So when alcohol reacts with a halogen acid with the anhydrous zinc chloride, this functional group gets replaced by the halogen group and you will get RCl plus CH2O. So water molecule is eliminating. So removal of water molecule from this is known as a dehydration. So we are using dehydrating agent, that is zinc chloride. So this process is Gru's process. The process is known as a Gru's process. So we can prepare the haloalkane from alcohol by using the halogen acid and anhydrous zinc chloride. So you will get haloalkane and byproduct as a water molecule. So we are removing the water means we have to use a dehydrating agent. So anhydrous zinc chloride is what? Dehydrating agent. Are you getting? So these are the simple reaction. Next one, you can also try with, take, let us consider R as a CH3OH reacts with HCl and another zinc chloride, then you will get CH3Cl plus H2O. So this is what? Methyl chloride or chloromethane. So this is your haloalkane. So R may be alkyl group, it may be aryl group. Okay, so you have to replace R. If they ask the general reaction, then you have to write down the first this reaction. If they mention the specific example, then you have to replace R by any methyl group, ethyl group or any alkyl group, and you have to write the R whether it is methyl or not. So you have to specifically mention. Okay, read the question carefully in the examination. If they ask the general reaction, then you have to write down as it is. If they mention the specific example, then you have to replace R by any alkyl group or aryl group. Fine. Okay, next one, when alcohol is treated with the NaBr and H2SO4. When alcohol is treated with the NaBr and H2SO4, if you reflex this, then you will get haloalkane, that is RBr, and also the byproduct is H2O. So NaBr, that is sodium bromide, in the presence of halogen acid, that is sulfuric acid. In the presence of sulfuric acid, you will get haloalkane along with the byproduct H2O. When alcohol is treated with phosphorus trichlorides or phosphorus pentachloride. Okay, if you treated alcohol with the phosphorus trihalides or phosphorus pentahalide, specifically phosphorus pentachloride, then you can prepare the haloalkane. So for example, when ROH, that is alcohol, treated with a PX3, X means what? Any alcohol group, Cl or Br, etc. Okay, then you will get 3Rx, that is nothing but Rx means what? Haloalkane, along with the H3PO3, that is phosphorus acid, as a byproduct. So this is very important. Okay, sometimes in a final examination they can ask the question like this: what is the byproduct when alcohol reacts with a phosphorus trihalide? So byproduct is what? Phosphorus acid. Byproduct is what? Phosphorus acid. So in this manner also you have to study. So when alcohol reacts with the phosphorus trihalides, you will get 3 moles of haloalkane and the byproduct is phosphorus acid. Fine. Next one. Alcohol when reacts with the phosphorus pentachloride. Alcohol when reacts with the phosphorus pentachloride, it gives haloalkane, and along with the haloalkane you will get POCl3 and HCl as a byproduct. HCl as a byproduct. So this is also very important. So when it is reacts with a pentachloride, phosphorus pentachloride, then you will get only 1 mole of haloalkane. But when it reacts with the phosphorus trihalides, you will get 3 moles of haloalkane. So this remember. Okay, this you have to remember. And the byproduct is HCl and POCl3 when it is react with the phosphorus pentachloride, but when it is react with the only phosphorus trihalide, then H3PO3, that is phosphorus acid, is the byproduct. So you should know the differences. Fine. Next one, when alcohol reacts with the pyridine in the presence of SOCl2, in the presence of SOCl2, then you will get haloalkane along with the sulfur dioxide and HCl gas is liberated, and this process is known as Darjan's process. This process is known as Darjan process. When the alkyl chloride can be prepared by refluxing. The alkyl chloride can be prepared by refluxing alcohol with the pyridine in the presence of small amount of pyridine is called Darjan's process, and SOCl2 is known as what? Thionyl chloride. SOCl2 is known as what? Thionyl chloride. So the alcohol reacts with the thionyl chloride and it liberates the HCl, that is acid. To maintain the reaction or to neutralize this acid, we have to use the base pyridine. So that is the purpose of pyridine we are using in this reaction, because when alcohol reacts with the thionyl chloride, it releases the HCl. Okay, so this reaction becomes acidic in nature. So to neutralize this reaction or to neutralize the acid, we have to use the base. So pyridine is what base. So the purpose of using the pyridine to neutralize the HCl. So you will get alkyl chloride and sulfur dioxide gas is liberated, and HCl also. To neutralize HCl, we are using what? Pyridine. So this process is known as what? Darjan's process. This process is known as Darjan process. So one note is here, in Gru's method, zinc chloride is used to weaken the carbon OH bond. In case of tertiary alcohols, zinc chloride is not required. The reactivity order of halogen acid is Hi is greater than HBr than HCl. Darjan procedure is the best method for preparing alkyl halides from alcohol, since both the byproduct are SO2 and HCl are gases and escape easily, because SO2 and HCl gas are gases and they can escape readily. So this method is very good for the preparation of alkyl chloride. So this is about the preparation of haloalkane from alcohol. So this is very important, guys. Remember. Next, preparation of haloalkanes. Addition of hydrogen halides on alkene. So addition of hydrogen halides on alkene. So we get two name reaction in this. And these name reactions are very much important for the final examination for 2 marks. Okay. So these reactions are very important. The first one is known as Finkelstein reaction. Where chloro or bromoalkanes are heated. With the concentrated solution of sodium iodide. In acetone. So iodoalkanes are obtained. And this reaction is known as Finkelstein. So Finkelstein reaction is used to prepare what? iodoalkane from chloro or bromoalkane. So this reaction, what is happening? We are exchanging only halogen from the alkyl halide. So we are exchanging the halogen from the alkyl halide. So in the reactant hand side, what we are having? We are having alkyl chloride or alkyl bromide. But when it is reacted with the sodium iodide, solution of sodium iodide in the presence of acetone, then what happens? The halogen will get exchanged. Only what? Halogen will get exchanged. So NaI. So this is exchanging. NaX, you will get NaX, and what is remaining? Ri. Okay, that is iodoalkanes. So Finkelstein reaction is used to prepare the iodoalkane from alkyl halide in the presence of solution of sodium iodide. So this one is important, and dry acetone. So whenever, suppose this reaction you will get, so based on the reagents present on the arrow mark, acetone and the sodium iodide, you have to judge the name of the reaction. If sodium iodide is present and acetone is present, then it is Finkelstein reaction. Then what you should write? Iodoalkane as a product and NaX as a byproduct. NaX as a byproduct. So this is the name reaction, very important. That is Finkelstein reaction to prepare iodoalkane from alkyl halide. Next one is a SWOT reaction. Next one is what? SWOT's reaction. Before that, let us try some example for Finkelstein reaction. Suppose I am having CH3Cl, okay, and if I react with a sodium iodide in the presence of acetone, then what we will get? First we have to remove this NaCl. What is remaining then? CH3I. So this is the product, CH3I plus NaCl. So CH3I is what? Methyl iodide, right? Or iodomethane. So this is your Finkelstein reaction. That is the example. Next one is a Swartz reaction. So Swart reaction is also same halogen exchange reaction only. Fluoroalkanes, but here we are going to prepare the fluoroalkanes, not iodoalkane. Iodoalkanes mean Finkelstein, fluoroalkane means Swart reaction. So fluoroalkanes are prepared by heat, by treating alkyl chlorides. By treating alkyl chlorides or alkyl bromides with a salt such as mercurius fluoride, maybe a G2F2, that is known as mercury fluoride, or silver fluoride, okay, cobalt fluoride, COF2, SbF3. Okay, by using these reagent we can prepare the fluoroalkane from alkyl bromide or alkyl chloride. So this is your alkyl bromide, CH3 methyl bromide. If you use this AgF, okay, then what is byproduct? AgBr, and remaining is what? CH3F. So very beautiful reaction it is. We have to prepare the fluoroalkane, then we have to carry out the Swart reaction. Swart reaction. Remember AgF. And how to remember this reaction? That is simple. You know the latest movie is coming, right? KGF, right? Chapter 2. So instead of KGF, AGF. Okay, so KGF and AGF. Instead of K, what is we are having? Silver. So if AGF is there, then it is Swart reaction. Okay, it is Swart reaction, and you have to remember such tricks. You have to use to remember the reaction. Then you will get fluoroalkane as a product and silver bromide as a silver salts of bromides or halides. These are the byproduct. Next, Hunsdiecker reaction. So this reaction is not there for your syllabus, but let us try to learn some new reactions also. Okay, so when CH3CO, silver salt of acetic acid is used, silver salt of acetic acid reacts with the bromine in the presence of non-polar solvent, that is carbon tetrachloride. Okay, then we get the bromoalkane along with the silver bromide, and carbon dioxide is eliminated. So in order to prepare the alkyl bromides, then the beautiful reaction is what? Silver salt of acetic acid is treated with the bromine in the presence of carbon tetrachloride, then you will get CH3Br and AgBr and CO2. So these are the reactions, very much important reactions are what Finkelstein's and Short reaction. These two reactions you remember. Finkelstein for the preparation of hydroalkane, Short's the preparation of fluoroalkane. Reagent is here sodium iodide, here is KGF, that is AgF. Okay, so in this manner we have to remember the tricks. Okay, in this manner we have to remember the tricks to identify the reaction, because in examination they can ask anything. They can give the reactant and they ask the product, or they can give the product, they can ask the reactant. Okay, so such type, in this type also they can ask reaction, so you should prepare from both the side. If they ask reactant, then you should answer. If they ask the product, you should answer. So entire, if you practice this reaction 4 or 5 times, then it will become perfect. Okay, just remember what are the reactant, what is the reagent, and what we have to write in the right hand side. So this is about today's class. So we will stop here, and further things we will study in our next class. So thank you one and all, but try to practice the reaction as much as possible, because organic chemistry is like this only. Unless and until you cannot try, you will not get it. So practice makes man perfect. Yes, I know that practice makes man perfect, but perfect practice makes man perfect. So daily you have to sit and you have to solve at least 10-15 reaction repeatedly. Then only you can identify the reaction. Got it? So practice more, try to understand the concept. Okay, it will become easy for you. So thank you one and all.